Okay, so we are trying to simplify by removing constants and parameters from the original differential equation. So first we're going to try by putting n equals py, we're going to change this differential equation here. So where n equals py, here we go, so when we do dn dt, we've now got dpy dt, and we've got k, n is py, oops, I'll just write py, and we've got p minus n is py. That's what we'll end up with. Alright, so just remember this p is a kind of a constant, so it is, so we can put it out the front and say p dy dt is equal to the other side. So we can cancel the p's and you can see dy dt will be k y. I'm going to factorize by p here, kyp, 1 minus y. And we're also using r equals kp, so we have a kp here, so this will be ry is 1 minus y here. And remember that to find our initial conditions, so when our t, because we've still dy dt, so when t equals 0, we know that from here, we know that n equals, so n is called n0, alright? So therefore, because y equals from here, if I rearrange that, y equals n on p, then y0 is going to be our n0 on p. Alright? Alright, and then so the second one says, let's put in, here we go, so the second one says let's put in x equals rt, x equals rt to obtain a differential equation in terms of y and x alone. So I want a dy dx or a dx dy, but in this case, if you think about it, we've got over here, this side, we've got dy dt, so if I used dy dt and times by dt dx, I would have dy dx, which would give me what I want. So let's have a look. We're using x equals rt, and if I find I want dx dt or dt dx, but it's okay, so that will be r. So you can see that here we're going to get what we already have, so ry, 1 minus y, and we're going to multiply it by the reciprocal of this, which is 1 on r. So I'm just going to rub that out so I can do it. So now I've got 1 on r here, you'll see that cancels with that, and we just get y, 1 minus y, and that's in terms of just x's and y's, so we're all good there. The initial condition here being, so again, y0 being equal to some initial condition, y0, where y0 is n0 on p. So if you think about it, when we're talking about when x equals 0. So when x equals 0, t is equal to 0. And so when t equals 0, we know we're getting our original, so that's at the beginning, we're getting back to our original n0. So n0 on p would be our initial y. Okay, so we can just say y0, which is the same as n0 on p. Alright, so then we're going to, I'll just get rid of this. I don't think I need that. I'll go this side. So now we want to make the substitution v equals 1 on y to get a differential equation in v. Alright, so we're going to do the same thing. V equals 1 on y, or y to the negative 1. So dv dy equals negative 1 on y squared. So if I want, at the moment I've got dy dx. So if I talk about dv dx, because I've got dy dx already, and I can just use what I've just done, which would be dv dy. There we go. So I'm just using, usually that's what I'm doing, I'm using what I've already got from above, and then I'm going to just differentiate to get this one. So this is minus 1 on y squared. So if we have a look at this one, I get negative 1 on y, 1 minus y, and remember that v equals 1 on y, so this is going to be negative v 1 minus 1 on v. And if I expand that out, I'll get that negative v, and then I'll get 1. So I'll put it that way. So, so this is now a differential equation in v. And if we basically now it says find the general solution for v here. So part D, find the general solution for v. So we are going to integrate and see if we can find it. Now the v's are all on this side and we want them on the other side with that to v. So what I'm going to do is have to put them downstairs, as it were, divide by it. So I'm going to have 1 on 1 minus v with respect to v, integral with respect to v, and the other side will be dx. There's just a 1 left there. I don't want a 1 minus v. I want I'd have to have a negative 1 on top. So what you could do is do that and balance it, or you could just multiply both sides by negative 1, like that. And this would give us a 1 on v minus 1 to v, and now this will give us a negative 1 dx. So now this is a log, and nice log, and this is a minus x plus c. If I go to exponentialize that, I will get e to the minus x plus c, and that plus e to the plus c I can just make a, so it's going to be a constant. And then that bit, I might add 1 so I can put v as the subject. So if I then wanted, so hence write down this corresponding solution for y. So there's my general solution for v, but in terms of y, remember back to here, v equals 1 on y. So y is the reciprocal of v. So if I reciprocate that, I get to there. Okay, all right, so then we have to apply the initial condition to evaluate the arbitrary constant. The arbitrary constant being a here, because x and y are variables. So we need to find a, and then we're going to simplify. All right, so remember our initial condition being n0 on p here. y0 is n0 on p. So when my t equals 0, which means my x equals 0, my y0 will be n0 on p. So here I've got, here, the y will be n0 on p, and here I've got a e to the minus 0, so that's just 1 plus 1. So you can see here then my 1 plus a is going to be, so if I reciprocate, it's going to be p on n0, so my 1 plus a is going to be p on n0, so my arbitrary constant a will be this, take away 1. So if we now, I might actually put it as a common denominator. There we go. So if that's my a, let's go back to the original, where's my y, which of course I've lost. But hopefully you wrote down from before. So my y is equal to, oh here it is, it's right here. 1 on, so I'm kind of working backwards now. So 1 on, my a here being p minus n0, just right, so p minus n0 on n0, e to the minus x plus 1. If I multiply all terms by n0, that will get rid of that fraction in a fraction. There we go. Alright, so that's my y. So I've simplified for y, hence determine the solution of the original. Alright, so having gotten to there, let's have a look at the original, and I probably rubbed out what I needed. Okay, so remember that n equals, we started with n equals py. So n, if I want in terms of n, which I do because I want dn to t here. So n is p times y. Well, we've got y, so I'm going to multiply y by p. So that's not too bad so far. And the other thing is, I've got p minus n0 e to the minus x. But I don't want x, remember, this is what I'm looking for, my solution to this. So remember that x equaled RT, or equals RT from here, and R was, where's R? R is KP, so put KP in there. So X is actually equal to KPT, so e to the negative X is e to the negative KPT. There we go. So hence, this should be our solution for our original differential equation.